Hi class, this is lesson 10.4, Inscribed Angles and Polygons. So an inscribed angle is an angle whose vertex is on a circle and whose sides contain chords. So chords of the circle. So this angle right here, this is an inscribed angle. Its vertex is on the circle, and then these sides are chords. The next one, the arc that lies in the interior of an inscribed angle has endpoints on the angle, is called the intercepted arc. Of the angle. So the arc that lies in the interior of an inscribed angle, that would be this right here, and it has endpoints on the angle, is called the intercepted arc. So this green arc right here, there's my intercepted arc. Okay, so theorem 10.7, the measure of an inscribed angle theorem, says the measure of an inscribed angle is 1/2 the measure of its intercepted arc. Okay, so the measure of this angle is going to be half of this arc. So the measure of angle ADB equals 1/2 the measure of arc AB. So let's look at our picture here. Example 1, use inscribed angles. It says find the indicated measure in circle P. So A wants us to find the measure of angle S. So angle S is right here, and 60 degrees is the measure of the arc, so the angle is half of 60 degrees, which is 30 degrees. The next part says the measure of arc RQ. Well, arc RQ is right here, and since this angle is 60 degrees right here, let's figure out the rest of them. This one right here is going to be 37 degrees times 2. So that one would be 100 and, well, it doesn't really matter what that one is. It's 74. But because this is a diameter right here, I know this 174 and this angle right here have to add up to 180. So I can do 180 minus my 74 degrees. And that would give me 106 degrees. So again, I use the idea that double 37 is going to give me 74 degrees for this arc. Because this is a diameter, these two arcs would have to add up to 180 degrees. So try this next one on your own, pause it and try it, and then come back. Okay, so it says find the indicated measure. So number 1, the measure of angle GHJ. So angle GHJ is right here. We want to find this angle. Well, this arc's 100, so half of 100, because I know the arc's twice as big as the angle, is 50 degrees. So that angle is 50 degrees. Number 2, the measure of arc CD. Well, arc CD is right here. My angle's 40, so the arc is twice as big. Just a second here. Okay, so as I was saying, to find the measure of arc CD, we know the angle B here is 40 degrees, so if we do 2 times 40 degrees, that'll give us our arc measurement, and that is 80 degrees. Okay, example 2, it says find the measure of arc HJ and the measure of angle HGJ. What do you notice about angle HGJ and angle HFJ? All right, so if we want to start with the measure of arc HJ. Arc HJ is right here. This angle is 39 degrees, so I know this arc is 2 times 39 degrees. So that arc is going to be 78 degrees. Now, I also want to find the measure of angle HGJ. So let's figure out where that is at. HGJ is right here. Now, this intercepts the exact same arc, so I know this angle must also be 39 degrees because it's got the same arc that it's intercepting. So what do you know about angle HGJ and angle HFJ? They are the same. So on your own too, again, you should pause it and try that one. Okay, wants the measure of angle RTS. So RTS is going to be right here, and it intercepts this arc, and this angle intercepts the same arc. So angle RTS has to be 31 degrees as well. They have to be the same thing. All right, let's turn the page over. Theorem 10.8 says if two inscribed angles of a circle intercept the same arc, then the angles are congruent. So angle ADB is congruent to angle ACB in this picture, and it's just like the problems that we just looked at there. So using theorem 10.8, it says example 3, name two pairs of congruent angles on the figure. Well, we're going to know that angle SPR is congruent to angle SQR. Those are going to be congruent to each other. And we're also going to be able to say angle PSQ is congruent to angle PRQ. On your own 3, it says name the other two pairs of congruent angles in the same figure. Well, there's only two pairs of congruent angles in this figure, so, well, I guess you could say, and I can just mark them because we don't have names, these two angles are congruent, and then the other two would be, those two are congruent. Not a great picture because this is using vertical angles. That's an idea from GOA, not one that we've looked at recently here in GOB. Okay, let's look at theorem 10.10 here. It says a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So remember, it's an if and only if statement, so that means if this is true, then this is true. If this is true, then this is true. So it says D, E, F, and G lie on circle C. If and only if the measure of angle D plus the measure of angle F, because they're opposite each other, equals the measure of angle E plus the measure of angle G, and those both equal 180 degrees. So the key here is opposite angles are supplementary in an inscribed polygon, or in an inscribed quadrilateral, I should say. So example 4, we're going to use theorem 10.10. It says find the value of each variable. So I know these are opposite angles here. So I know x plus 88 has to equal 180 degrees. So if I solve that, I'll know that x equals 92 degrees. These two angles across from each other have to add up to 100 as well. So y plus 100, they have to add up to 180. I said 100. They have to add up to 180. Solving it for y, you get y equals 80 degrees. Looking at part B here, again, opposite angles have to add up to 180, so we can write 8x plus 4x equals 180. So that means 12x equals 180. Divide them both by 12, and x would equal 15. For the second part, we know these two opposite sides, again, have to add up to 180. Now, opposite sides, opposite angles. So 3y plus 3y equals 180 degrees. That means 6y equals 180 degrees. Divide both sides by 6, and you'll find that y equals 30 degrees. Not 30 degrees, that doesn't seem right. Yeah, 30 degrees, that is right. All right, on your own 4, it says find the value of each variable. So again, we know opposite angles have to add up to 180 degrees because this is a quadrilateral. So these two across from each other, 4b plus 96 equals 180 degrees. If I subtract 96 from both sides, I have 4b equals 84. Divide them both by 4, and you'll find that b equals 21. Again, my opposite angles here are going to be supplementary. So 5a plus 90 equals 180 degrees. Subtract 90 from both, and you get 5a equals 90. Divide both sides by 5, and you'll find that a equals 18. So a couple ideas here about inscribed angles and inscribed quadrilaterals. Make sure if you have any questions, you ask me about it in class, and have a great night.